Okay, let us continue with thermal deformation. This is somehow just a continuation to strain topic. Remember that strain was the ratio of deformation per unit length, and that we had the description of modulus of elasticity is just a ratio of stress over strain. That's why we got the formula PL over AE. Remember this one. So since stress is P over A, and then that strain is deformation per unit length, we had this one equated to E. And that we have the formula of deformation. But this time, let us proceed with thermal deformation, since the reason why we had the connection with the previous one within the axial deformation, because there would be certain force that will act on the system that somehow be a tendency of being an axial force in relation to thermal changes. So whenever mo consider ta og thermal um, drop and rise of temperature, then there would be an action to internal forces inside the fiber, and then because of the dropping or the increasing of temperature, then we collectively get the force inside as the axial force, and that we could relate it into the axial deformation. So somehow, whenever there is an increase or decrease of temperature, we will consider maybe there's zero stress in the beginning, or there is already stress whenever we consider thermal deformation or thermal changes. So when we say thermal deformation, then it's going to be um, the product of thermal expansion, or the expansion coefficient of the material, and that is to be multiplied by the change of the temperature and the unit length. That's thermal deformation. So thermal deformation, or sigma, delta T is equal to thermal deformation, and that's in mm or in inch. We would appreciate, or we would kind of distinguish that deformation in mm or in inch instead of in meters or in feet. And then alpha is the coefficient of linear expansion, and that's in meter per meter degrees Celsius, or just 1 over degree Celsius, or inch over inch per degrees Fahrenheit, or that's 1 over degree Fahrenheit. And L here is the length of the material that we are using, and the change of temperature may be in degrees Celsius or in Fahrenheit, and that's equal to the final temperature T2 minus the initial temperature T1. Let's have example number 1.